Hi everyone, in this video we're going to look at a special case of factoring. It's called factoring a trinomial. Now recall polynomial meant many terms. So trinomial, it means three terms. Something like an x squared plus 5x plus 6. And these are all three different types of terms because, well, the first has x with an exponent of 2, the second one has an exponent of 1, and the third one does not have an x term, which is to say it has an exponent of 0. So over the course of this video, we will learn a bunch of different ways. I'm going to start with the first one, which is the area analogy method. We're going to use the fact that area of a rectangle is given by length times the width. So for example here, if it's 2 by 4, then the area is 2 times 4, which is 8 squared units. Okay, now how we are going to use this is that you're going to observe that we can look at these algebra or algebraic terms as rectangles. Namely, anything that is x squared can be thought of as a square with sides x and x. Then x squared represents the area of that rectangle. Similarly, a term x can be thought of as a rectangle that is x by 1. Then the area is given by 1 times x, which is x. And similarly, 1 can be thought of as a square 1 by 1, whose area is given by 1. This means that the algebraic expression x squared plus 3x plus 2 can be visualized as 1x by x square, 3x by 1 rectangles, and 2 1 by 1 squares. Okay, now what does this plus indicate? This plus, we are going to think of them as we are given, one of these, and then we are given 3 of these and 2 of these. And I'm going to think of them as, let's see if they can be rearranged. Okay. Now when I rearrange, I'm going to start with my biggest piece on the left hand side. And I notice that I've got 3 of these x by 1 rectangles, and I can actually take 2 of them and place them this way, and I can place one other like that. And when I do that, I can perfectly fit the other 1 by 1 squares here, and in this rearrangement I get a big rectangle. Now this big rectangle, what is the area of this big rectangle? That's going to be this side, which is x plus 2, times this side, which is x plus 1. But the area has not changed, meaning the area of the small pieces must equal the area of the new combined object. That is to say that x squared plus 3x plus 2 must equal x plus 1 times x plus 2. And this, as we have seen before, is a factored form of the expression. So this is the first method, which is we convert the algebraic expression into a bunch of puzzle pieces, And the goal is to put these puzzle pieces together to form a bigger rectangle. Okay, let's try it out for these two. So here I have one big square, and then I have 5 pieces of x by 1s, right? Now these 5 pieces of x by 1s, they can be distributed in many different ways. For example, if I put all 6 of them here, right? 5, 6. This is a rectangle, but there's no use for these. I don't know where, there's no place for these 6 rectangles, which means that's not going to work. Now let's say I put 5 of them there and I put 1 there, but now I have 1, 2, 3, 4, 5 spaces, but I have 6 pieces, so that's not going to work either. So I remove one more. Let's say I have 4 there and I have 2 here. Now I have 1, 2, 3, 4, 5, 6, 7, 8 spaces and only 6 pieces, so that's not going to work either. So let's remove one more. So I have 3 and I have 2. Now I have 1, 2, 3, 4, 5, 6. That seems like it's going to work because now I have exactly 6 pieces, and those 6 1 by 1s are going to fit in here to give me a big square, or sorry, a big rectangle. And this side of the rectangle is x plus 3, and this side is x plus 2, which means that x squared plus 5x plus 6 is going to equal x plus 2 times x plus 3. Okay, so this is the visual way in which you can try this out. You can pause the video and try this one right here. Now the only difference is now you have 2x squared, so when you start, you have 2 of these big boxes, and then you have 3 small boxes, so I'm going to fit them as 1 and then exactly 1 small box, right? So this is going to be 2x plus 1 times x plus 1. So that's the visual way of factoring these trinomials using rectangles and moving them around to form larger objects, and using the fact that when you move around these pieces to form a bigger object, then you don't lose any material, meaning you don't lose any area. Okay, that's the first method. Next we will look at an algebraic result and see what is another way in which this same process can be illustrated, maybe without using areas and without using rectangles.